Welcome. In this video, I'm going to demonstrate column chromatography. Now, by this time, you should have already done the thin layer chromatography and have some experience with chromatography and how the technique works. Compounds of like polarity attract each other, and so in the thin layer chromatography, we used a polar support, which was silica gel, and we separated a mixture of polar and non-polar components by the selective adsorption onto the silica gel. And column chromatography is just the big brother of thin layer chromatography. In this case, our stationary phase is not going to be silica gel, but it's another polar solid called alumina. And that'll be our stationary phase, and our mobile phase in today's experiment will be petroleum ether and dichloromethane. Those will be the mobile phases. You use column chromatography to separate larger quantities of material than what you would do in thin layer chromatography. You recall in thin layer chromatography, we crushed a leaf and we separated the pigments, and we were dealing with micrograms and those little dots, extremely small amounts. Well, what if you had some real quantity? How were you going to separate it? Well, column chromatography is a good way to go. I used this in graduate school, ran a reaction a few times, made, fortunately for me, all the compounds, all the products of my reaction were colored. And so when I ran the column chromatography, I had a series of red, orange, and yellow bands that I could cleanly separate. So, and then I could isolate the individual products of that reaction. At that time, I was the first person to do that reaction, so these were all new compounds, and I didn't know what I had, so I had to isolate these things and identify what they were. So it's a very common technique in chemistry. So now I'll show you how to set up the apparatus. All right, for this part of the experiment, I'm going to put the gloves on. These are some chemicals that they're not extremely hazardous, but you don't want to get them on your skin. They will dry your skin out, and ladies, if you have princess skin, you may be extra sensitive and complain you have dry hands and stuff. And so wear the gloves. That's my advice. The compounds that we're going to separate today, there are two of them, and structurally, chemically, structurally, they're very similar. One of them is a yellow compound, and that's called 9-fluorinone. And it has a colorless cousin that's missing a carbonyl group, and that compound is relatively nonpolar and it's white. So we're going to separate today a mixture of a colorless and a yellow compound. Now the stockroom has prepared this one-to-one mixture of the colorless and the yellow compound, and of course to us it looks yellow because the yellow color dominates. But trust me, there's colorless material in here, and we'll separate it today on the chromatographic column. So to do this experiment, we need, this will be the column that we use. It's kind of this short little burette with a round top, stopcock at the bottom. My advice is always check this stopcock and make sure you have one that turns easily. You don't want this thing to, if it's loose, it's going to leak around the bottom, and the mobile phase will just drip all over the bench. So make sure it's snug, but then it's not too snug because you've got to be able to open and close this thing. So check the stopcock. And then before we load the column, make sure the stopcock is closed. Otherwise, it goes on the bench and then on to you, and then you go in the shower. So make sure the stopcock is closed. Before we load any of the stationary phase in, we have to follow this procedure. We're going to put a cotton plug in the very bottom of the column. So I have a small piece of cotton that goes in the top here, and then we'll provide you a copper wire, and with great skill you will push the cotton plug to the bottom. Now we don't want too much cotton, because you'll find too much is not good. It'll inhibit the flow, and what that means is you'll get the mobile phase will drip out, but it'll be very slow. And so we'll be here for a day and a half while you're waiting to collect your mobile phase. Everybody else has gone home. So not too much cotton. On top of that layer of cotton, we're going to put a layer of fine sand. So this is not the sand that's used in the sand bath. This is fine, they call it beach sand. So I don't know if it's California beach sand. It looks too clean for that, but it's really fine sand, not that coarse stuff that we use in the sand bath. So we're going to put in a little bit so that we get about a centimeter layer of fine sand. All right, that's good enough. Now, the purpose of the cotton is to keep the sand from coming through. The purpose of the sand is to keep the alumina, which is really fine. If you think the sand was fine, wait till you see the alumina. Here it is. You're supposed to weigh out 5 grams. Here it is. This is an extremely fine powder. I don't know if you can see how fine that is, but it makes the fine beach sand look coarse. So we're going to load that in our next step. Now, in the next step, they want us to add 25 milliliters of petroleum ether to the column. Now, you may recall petroleum ether is not really an ether at all. It's a hydrocarbon fraction when they make gasoline and such. Petroleum ether is classified by its boiling point, and the stuff we're using today is 3060, which means it's a mixture of hydrocarbons that boil between 30 and 60 degrees centigrade. So it's pretty volatile material. And here's 25 milliliters. They want us to load 25 milliliters into the column. So here we go. Oop. I need the glasses on. Now I'm better. Into the column. Now we'll add this 5 grams of the really fine alumina. And you can pour it in, or you can use a funnel, direct it right over the opening. That's maybe a little better idea. And so look at the alumina as it falls down. What we want to do is make sure that it packs solidly. So as the alumina settles, it's a good idea to tap the column. What we're trying to do is have the alumina pack in such a way that there are no voids or cracks when it settles. So tapping the column helps with that, helps with the settling, helps minimize or avoid cracking and voids. All right, we're just about done. All right, so they wanted us to use 5 grams. You can see 5 grams doesn't really fill up much of this column. This column can handle, what, 4 times that amount, but 5 grams only fills about a quarter of the column. But that's what they want. Now, on top of that, we'll add a little more sand. Now, the purpose of this layer of sand is so that when we add the compounds that we're going to separate, that we don't churn the alumina. You don't want to churn the stationary phase. We're trying to have the compounds go on as a thin layer on the top, and if we squirt the compounds in and it all swirls around, then you're not going to get a clean separation. So to avoid any agitation at the top of the column when we add the fluorine and the fluorinone, we're going to put another layer of sand on there, so about another centimeter. Yeah, it ought to be plenty. All right, so I hope you can see that. Cotton, sand, alumina, sand. Next step, they want us to start draining the column. The intention here is to drain the column until we get this liquid level down to the top of the sand. When the liquid level gets to the top of the sand, that's the point where we will load on the two compounds that we're going to separate. So you can see this is taking a while to drip. While this is going on, I'm going to make up the sample. So to make up the sample, they wanted us to take 1/10 of a gram. I measured out yesterday. They want us to put this in a test tube. By the way, when you measure this out, you'll measure it out accurately, so to the nearest milligram, because we're going to determine our percent recovery at the end. We're going to measure the amount of material that we recover. So let's say we added exactly 100 milligrams, and you may recover 80, then your overall recovery is 80%. So like most of these techniques, we're going to suffer some losses. I can see that the dripping here on this column, while it's going, it's okay, but it's a little slow. I use too much cotton. The drip rate should be faster than that. Can you see that? I don't know, it's faster than a drop a second, but still it's going to be rather slow. So I wish I'd used a little less cotton. So do as I say, not as I do. We're going to leave that go because I think I've got plenty of time to make up the sample. Put the sample in the test tube, and they want 1/2 milliliter of petroleum ether. Which is not very much. About 10 drops. All right, so the petroleum ether goes in on top of our fluorine-fluorinone mix, and I can try agitating it, and you can probably see it doesn't dissolve. Okay, so now what they want us to do is add a little dichloromethane, drop-wise, until we get this to dissolve. So I got a bottle of dichloromethane. Now the two compounds are very soluble in dichloromethane, so it won't be a problem getting them into the dichloromethane. But we're trying to do this with the minimum amount, so I'll put a couple of drops in here to begin with. And shake it up and see what happens, and not enough. Couple more drops. Shake, shake. Well, it's going in. It's going in. Maybe you can see. It looks like it's all gone in. No solid. So, I don't know, that took 4 to 6 drops of dichloromethane. Now we have everything in solution. Now we're ready to load it on the column. Unfortunately, I can't load it on the column just yet because I need to let this drain down to the top of the sand. So we'll be back in a few minutes when this thing has reached the top of the sand. All right, let's see if we still have fluorine coming out. Right now, we've got about, 5 inches of liquid left in the column. So let's see if the fluorine is still coming out. Oh, I'd say that's affirmative. So let's let it drop. We'll come back when the level's gone down and it looks like the fluorine level is dropping off. We'll resume the video. We're back now, and the level in the column is what? Now maybe 3 inches? Let's take a look and see if we still have some of the fluorine coming off. Well, you know, there's a residue there, but it's much less than before. So I think we're getting close. I think we're getting close to the end of the fluorine collection. We're getting close, I think. We've got maybe 2.5 inches. If you can, take a look where the yellow band is. There's now definite daylight here between the top of the yellow band and the top of the column. So the yellow band is moving down the column, albeit very slowly. So let's go back in here and see if we have any fluorine coming off still. Doesn't look like it. Very, very little. Now, I think we're going to continue to get very, very little. I'm going to shut this for a minute. We're going to continue to get very, very little as long as I've got this white ring around the bottom of the burette, because this ring is going to dissolve and end up on the watch glass. So we have to get rid of this, especially before we start to collect the next fraction. So what I'm going to do to get rid of that, I'm going to just dip that in the flask here and kind of wash off the end of that burette. We're finishing washing off the tip. We want to make sure we get that fluorine off of the end of the tip because we don't want it contaminating the fluorinone. So when I'm done washing it, I'll take a clean Chem wipe and wipe off the tip, and that should get rid of the fluorine. So now we have another fraction to collect, the yellow fraction, and it's got to move down the column. One way to do this is to just continue to let this go down till it hits the top of the sand, and then change polarity. This is the yellow material, the fluorinone, is a polar material, and it wants to stick on the column because the column's polar. If we make the solvent a little more polar, this will move a lot faster. So a good way to do that is to add a slightly more polar solvent, and for that we're going to use dichloromethane. Remember, dichloromethane was what we used to dissolve the mixture in the first place. We had a little PET ether and dichloromethane mix, and we loaded the column. And now I'm going to suggest we do the same thing and add some dichloromethane to the petroleum ether that's already here, and it should move this much more rapidly down the column. It's not going to help my drip rate, but it will help move the material a lot faster. So I think what I'm going to do is just take about 10 milliliters of dichloromethane. I'm going to pour it right in on top of that. And you say, well, what about the mixing? The mixing's not that great. And I don't care. I don't care. It'll mix a little bit, and the change in polarity will be gradual as the nonpolar PET ether comes down, and then you'll have this layer where the methylene chloride mixed with the PET ether, and then it'll gradually become more concentrated in methylene chloride. And that's good, because a gradual change in polarity is good for this column. A rapid change in solvent polarity tends to cause voids and cracking in the column. So we want to avoid that. So I think we'll be all right. I'll just pour this in on the top. And there's some mixing going on. I don't know how well you can see that on the camera, but there is mixing going on. And now I'm going to take a clean 50 milliliter Erlenmeyer. Actually, you know what? I'm not going to take a clean 50. I'm going to take our original flask that had the original PET ether in it, and I'm just going to open the stopcock and let it drain into this flask, because this will be our waste flask. And when I'm ready to take the yellow layer, I'll switch back to the clean 50 milliliter Erlenmeyer. So what we should see is that the drip rate won't change, but the movement of this yellow band will start to accelerate as the more polar petroleum ether washes onto the column. So we'll see this move, I think, relatively rapidly. What I'm going to do is I'm going to watch this yellow band, and it'll get to the bottom of the column, and it'll get into the cotton, and I'll be able to see it in the cotton. And when the bottom of the cotton starts to turn yellow, that's when I know to make the switch. So I'm not gonna switch it here at the bottom of the column. I'll wait till the yellow color gets into the cotton, and then I'll make the switch of the flasks. So we've got about a ½ inch, it looks like now, between the yellow band and the top of the column. Let's come back in a couple of minutes and we'll see where the band is. All right, at our last look, we had about a ½ inch of white aluminum and the yellow band, and now you can see we've got more like 1.5 inches, and the yellow band is going into the sand, and I don't know how well you're going to be able to see this, but if you can, keep your eye on the cotton, because we're going to see the yellow start to go into the cotton. I'm at a different angle than the camera, so I can see it's starting to go into the cotton over here on my side. So I'm getting ready to make this switch. When the cotton starts to yellow, I'll just make the switch. And it looks to me like there's a faint yellow at the bottom, so I'm going to go ahead and make the switch, and we'll continue to collect. Now I've got plenty of liquid in the column to wash that whole band off of there. We don't need to drain this whole column. We're just going to run this until the yellow band is all gone, all off of the column. And at this rate, that'll be a couple of minutes with this drip rate, but we'll be done in a few minutes. I don't know how well you can see it now, but the cotton is definitely a yellow color. Yellow is coming through. I put a piece of paper towel under here so maybe you can see that the liquid that we're collecting now is yellow colored. So we're definitely collecting the 9-fluorinone, and it should be off the column in another minute or two. I can see that there's still some up over on this side. On this side, it's pretty much washed off. So another minute or two, and this will be done. Well, we're back, and I think we're almost done. If you look closely at the column, you see the column is all white now, and there's a faint yellow color in the cotton. The fluorinone has eluted from the column, a little bit left in the cotton at this point, but you should be able to see that we definitely have yellow liquid in the flask. So we've captured most of the fluorinone. So you can see that we've collected yellow liquid in the flask. So we've collected most of the fluorinone, and for the purpose of this demonstration, I think I'm going to bring an end to this at this point. There's a little bit of yellow color still left, so if I were doing this for real, I would let this drip a little while longer, but I think for our purposes, we're essentially done. So I'm going to shut the stopcock. Now, part of the thing I need to teach you about is how we're going to have to deal with this solid and liquid that's in this column at this point. And a good way to deal with it is just keep this thing draining. Just let the column go dry at this point. That was what you wanted to avoid at all costs. You never wanted the column to go dry while you were doing the experiment or before you loaded the material on, or any time during the chromatography. That would be bad. But at this point, we want to get the liquid out of here, and we'll just leave this go while we deal with the two flasks with the material in it. And so we have the flask with the colorless fluorine and the yellow flask with the yellow fluorinone. And I'll show you how to deal with that. So let's leave this go. What I want to do when this gets dry, in order to clean the column, what we'll do is we'll tip this upside down into a plastic, one of the big plastic ice containers, and we kind of bang it on the plastic gently, And when this material is dry, it'll actually shake out of the column and fall into the bucket. And so we can clean the column relatively easy as long as the alumina is dry. So let's just let that go to dryness. In the meantime, let me tell you what we're going to do with these materials. We had this watch glass. This was a watch glass where we were collecting the fluorine. So what I want you to do is take the watch glass and the flask with the petroleum ether containing the fluorine, take it over to the hood, take it to one of the hoods. And we don't have the hood turned on today, so I can't actually demonstrate this for you, but take it over to the hood, and what you're going to do is you're going to pour a little of this liquid right into the watch glass. And when it's in the hood, the air is sucking over that. You got to, and this will evaporate. This petroleum ether is so volatile, it will evaporate in a very short amount of time. Let me see if I can, well, first of all, I'll use a little hand heat. Little hand heat may speed up the process. You know, they say, cold hands, warm heart. But I'm the opposite. I got warm hands, so what does that say about my heart? But maybe you can see that where the petroleum ether is evaporating, it's leaving a white ring. I don't want to tip it too much or it's going to, there's still liquid there, it's going to spill off. But you see how as the petroleum ether evaporates, it leaves a white residue? That's what we're going to do. Now the book said, do a distillation to take off the solvent. Oh, that's way too tedious. By the time I set the distillation equipment up, I could have done this method in the hood and evaporated the material right on the watch glass. So you just repeat this procedure a few times. When it's in the hood with the air blowing over it, this will evaporate pretty rapidly. The same is true with the methylene chloride and the fluorine. So you need another watch glass, or maybe this one after you've cleaned it, and you'll do the same thing. You'll do the same thing with the methylene chloride and the fluorine. When the methylene chloride evaporates, or let's just put it like this, the crystals that we get of the fluorine are never quite as good as the white fluorine ones. The ones out of the methylene chloride seem to look a little wet, but their melting point is all right. Maybe you can see that there's a little bit of residue. There you can see as it evaporates, crystals are forming. I don't know how well the camera can pick that up, but all right, well, we're just partway through the evaporation of the solvents, but I think you could see we're going to get yellow crystals from the fluorine and white crystals from the fluorine. So you do this until you've evaporated all the solvent. The products then, the two materials, will be on these watch glasses. Make sure it's dry before you go to scrape it off. So when you're ready, you'll take the spatula and you'll scrape off the material on the watch glass and do it into one of those blue Wayne boats or on a piece of that thin Wayne paper, and you'll get the mass. So you'll want the mass of the white fluorine and the mass of the yellow fluorine. And if we total them up, in a perfect world, that would equal 100 milligrams. You'll find world's not that perfect. I'll be really surprised if you get 100 milligrams, 100% recovery. There are always going to be some losses. But that's how we'll do this experiment, and I hope this was helpful on showing you how to set up the column.